Welcome to the Cowasaki Audio YouTube channel. This is a test video of the Radioelec tracer with the Radioelec filament heater. That noise is my dog sneezing in the background, and this video is simply for me to make sure that the cameras are working, the microphones are working, and that I know how to use OBS and Premiere Pro. Parts of this video will be used together with more video when I do a full build and review of the tracer, which is an excellent device which I've had for a few months now. Please let me know what you think. Any suggestions I'd be happy to hear. But for the moment, just bear in mind this is just a test video. I did it in 2 takes, so it's not the best, and there was no script. So it is literally for me to test the hardware and work out how to use the software. Thanks a lot for watching, and just let me know. Thanks. This is the hardware we're going to be using today. This is the tracer by Lampemetra, and this is the socket attachment, and this is the heater. The heater and the tracer have both come from Lampemetra. This is basically my way of connecting the valves that I use most regularly. In this box we also have DuaKit 2, which is another device by Lampemetra, which we won't be using today, but basically this is a dedicated standalone valve tester. The valve panel consists of 9 inputs, which correspond to the pins for a nonal and octal socket. Pin 1 simply goes to pin 1 of the octal and 1 of the nonal. Here I have an extra addition which allows me to connect the filaments to a 12AX7 style socket valve, and then we have the plate, grid and cathode, which go to pins 1, 2, 3 or pins 8, 7, 6 depending on the position of this switch, which allows me to switch between triode 1 and triode 2, or triode A and triode B, without having to take the valve out of the socket or swap leads around, and basically allows me to also do comparisons of the 2 triodes for balancing purposes and so on. The tracer has a switch for connection to the PC or to the output for the scope, and there's a test and grid switch on there as well. Okay, now that we've got the tracer attached to the computer, I'm going to plug in a valve to test. The valve I'm using today is a Mullard ECC 83, which is the equivalent of a 12AX7. So I'm going to plug that into the dedicated socket for valves of that type, so that I can use the triode AB switch. First of all, I'm going to attach the filament heater, checking that the voltage is set to 6.3 volts. That's now plugged in, and I'll attach the colour-coded wires that I'd handily done previous. Okay, they are now plugged in, and I'm going to select triode A just for the moment. Okay, now that we have the valve in the socket, and it's had plenty of time to warm up. We've double checked the wiring to make sure everything's correct, and we're ready to run our first trace. The ECC83 or 12AX7 is a double triode preamp valve. It's regularly used in guitar amplifiers and other amplifier circuits, so it's a good one for us to do as a test. What I'm going to do is I'm going to run the test twice on first triode A and then triode B, so that we can see what difference there is between the two triodes on this particular valve. What we need to do when we run the tracer is we need to set up our test values. Now the test values I'm going to use for this valve are from -4 to 0 volts, and the other values you can see on the screen. Okay, so there are only 5 values to actually change, but basically they're now done, and we can start the test. So if we click on the measure button, what happens now is the tester goes through and it measures the output against various inputs, at -4 volts, then at -3, then at -2, then at -1, and then at 0. Okay, so basically there's 4 full sets of results for each triode, and as you can see from the screen, there's nothing at -4. The valve starts to have an effect at -3, up to the maximum of 0 volts. And in the bottom left hand corner of the screen are a number of parameters which are useful in checking whether or not that valve is suitable for the application, whether or not that valve is worn out or matched to another one, especially when you're designing a stereo amplifier, and you might want to make sure that the parameters for each channel are quite similar. Okay, so now we have the parameters. Sorry, now we have the results of triode A. I'm going to switch to triode B, and I'm going to run the full set of tests again. Okay, so because we have the triode switch, that was a quick job. So we can click on the measure button now and see what the output, how the output changes. Okay, so we can see that there is a little bit of difference, possibly around just under 10%. That wouldn't really be an issue for a guitar amplifier. Within 10% is absolutely fine. Within 10% is absolutely fine for a new valve, really, but especially in a guitar amp, where what would happen is it would amplify through one half of the tube, the first triode, then the second, so 10% wouldn't matter. What might be a problem is if you were using this in a stereo amplifier, and you were using this particular valve for channels A and channel B, and then another valve for channel A and channel B, and so on. 10% of the difference could be an issue, which is why the tracer is really good, because you can use that to find a valve where both the triodes are of a similar value. Unfortunately, the software doesn't allow you to run measure without clearing the screen. That would be quite helpful. So if there was a button for measure without clearing, you could see how the two triodes compare on the screen. But I did do a screenshot, so I'm going to just bring that up now, and we can see how that differs. So as you can see, we do have the difference, and we're looking at a difference of maybe 500 microamps at 0 volts, a difference of maybe 400 microamps at minus 1 volt, and a difference of maybe 20 to 30 at sorry, just move up, maybe a difference of maybe 20 to 30 at minus 2. As I said, not really a massive issue, and you can also compare these figures on the left hand side.